Hey everyone, let's talk about something that's happening all around us, all the time, even when we don't notice it. It's called energy efficiency. Sounds a bit technical, right? But stick with me, because we're going to break down what it really means. Okay, let's start with a super simple question. Have you ever gone to unplug your phone and noticed that the charger block is warm? Sometimes even hot. I mean, it's not supposed to be a tiny little space heater, so what is actually going on there? Well, that warmth, that's literally wasted energy. Think about it. You're paying for electricity to charge your phone, but some of that electricity isn't even making it into the battery. Instead, it's escaping as heat. And that simple idea right there is the absolute key to understanding this whole concept of energy efficiency. All right, so let's dive into our first section here, energy's unavoidable loss. Because it turns out this whole lost energy thing isn't some kind of mistake or a faulty product. Nope. It's actually a fundamental rule of the universe. Here's the deal. Anytime you try to change energy from one form to another, say from the electricity in your wall socket to the light coming from a lamp, it's never ever a 100% perfect trade. It's kind of like pouring water from one bucket to another. You're always going to spill a few drops. In the world of energy, some of it always gets spilled along the way, usually as heat. Okay, so if some energy is always getting lost, how do we actually, measure that? How can we tell how much is being put to good use versus how much is just getting wasted? Well, first, we've got to define what we even mean by useful. It's actually pretty straightforward. Let's stick with our light bulb example. The total input is just all the electricity you're feeding into it from the wall. Easy enough. The useful output is the part that does the job you want it to do. In this case, it's the light. That's why you bought the bulb, right? And then there's the wasted output. For a light bulb, that's the heat it gives off. I mean, unless you're using it to warm your hands, that heat isn't helping you read your book. It's just waste. And this is where the big idea comes in. We call it efficiency. You can think of it like a report card or a score for any device. It tells you exactly how good that device is at turning the energy you give it into the useful stuff you want, instead of just turning it into useless waste. So you might be wondering, how do you actually calculate that score? Is it some super complicated physics thing? Nope, it all comes down to a really simple equation. Let's take a look. And here it is. Seriously, that's it. It's just a simple fraction. All you do is take the useful energy output, so the good stuff, and divide it by the total energy input, everything you put in. Then you just multiply that by 100 to turn it into a percentage. That's it. So a higher percentage means, you guessed it, a more efficient device. Now, don't get thrown off if you sometimes see this exact same equation but with the word power instead of energy. It's the exact same idea. Power is just how fast you're using energy. So whether you're talking about energy or power, the principle is identical. Useful stuff out divided by total stuff in. Okay, enough with the theory and the formulas. Let's put this into practice and see how it works in the real world with an actual example. We're going to put a classic, old-school incandescent light bulb to the test. You know the one, the kind that was in every house for like 100 years. They get the job done, but as you're about to see, they're not exactly champions of efficiency. Okay, check out these numbers. Let's say we pump 100 joules of electrical energy into this bulb. And by the way, a joule is just a standard way to measure energy, nothing fancy. So out of that 100 joules we put in, how much useful light do we get out? Only 10 joules. That means a staggering 90 joules, 90% of the energy, is completely wasted as heat. Wow. All right, let's do the math. It's super easy. We just take our formula, useful output divided by total input. So we plug in our numbers. That's 10 joules of useful light divided by the 100 joules we put in. 10 divided by 100 gives us 0.1. And to make it a percentage, we just multiply by 100. And what do we get? A measly 10%. That's right. Our classic light bulb is only 10% efficient. To put that in perspective, for every dollar you spend to power that bulb, 90 cents of it is literally just going towards making the room a tiny bit warmer. Only a dime is actually making light. That's pretty wild when you think about it. And this is why all this matters so much. Let's compare that old incandescent bulb to a modern LED bulb. Look at that difference. Where the old one was about 10% efficient, an LED can be up to 90% efficient. The old bulb wastes most of its energy as heat, while the new one turns almost all of its energy into useful light. It's a total game changer. So, at the end of the day, higher efficiency really just means less wasted energy. Simple as that. It's about getting more bang for your buck from the energy you use.
And when we improve efficiency, the effects are massive. It saves you money on your bills, for sure, but it also means we're putting less strain on the planet. Less waste is just better for everyone. So I want to leave you with one last question to think about. As you go about your day, take a look around. Think about your car, your computer, your kitchen appliances. What do you think is the most inefficient thing that you use every single day? The answer might actually surprise you.